Hello everyone and welcome back. In the last videos, we discussed how to connect the right side here. This side includes the register R1, R2, the ALU and the bus. Today, we need to move to the left side, which includes many units also. For example, it includes the program counter, the memory address register, the decoder, the instruction register, and the RAM or the random access memory. So I want to ask you a question here. Which units from these units here we should start with today? Should we start with the program counter? Should we start with the memory address register? And so on. Let's take the program counter for example. Do you remember what the program counter is used for? From its name, it counts something, right? So it has a number that points to the next instruction that will be executed in the next cycle. That's why it is called the program counter. So it counts the number of instructions, or it counts for the next instruction that will be executed in the next cycle. So it depends on the instructions that we have in the memory. So we cannot implement the program counter, or we shouldn't implement the program counter before the RAM. The RAM should be connected before it. Let's take another example, the memory address register. As you see, the memory address register is used to determine the address of the RAM. So we can start with the memory address register, but in this case, I'll use some switches instead of the memory address register just to test the RAM. And once we test the RAM, I am going to remove the switches and add the memory address register. So also we need the RAM before the memory address register. By the way, you can start with the memory address register. It's okay. But I am explaining my implementation here, or my opinion here. You can also start with the instruction register, because the instruction register can take any command or any instruction, and we can put some switches here that refer to a specific assembly instruction. But it is better to start with the RAM, because the RAM will contain the instructions that the instruction register should work on. So what I want to say here, we should start with the RAM today, and that's what I'm going to do. Let's look at the IC datasheet of the RAM, and as you see, this is the IC number. We have many numbers here starting from 54 or 74, LS or S, but I'm not going to explain these differences. You can use any LLM tools to understand the differences here. But we need to focus on this part, on this line and this small paragraph here. So as you see, it is called 64-bit random access memory, and it has something called 3 state outputs. So if you look at, let's say the 189 is a high-speed 64-bit RAM. The 64-bit RAM is organized as 16 words by 4-bit array. How can we understand this? Let me show you an example. It looks like this. We have a block like this one, and then we have some words or some locations up to a number here. We can say that this is number 1, and also, by the way, you can refer this as the address. Okay, so 0, 1, 2 up to, let's look at the data sheet again. It says 16 word, so it is up to 15. Okay, 16 words means 16 locations or 16 addresses is here. And 4-bit array refers to the size of each word. So the size here is 4 bits. And by the way, this is what we need. We do not need a size of 8 bits, a size of 32 bits, because our bus here is 4 bits or 4 lines. And from the beginning, we called our course 4-bit CPU design. And that's why every component here consists of 4 bits. So that is how it looks like. Now let's look at the IC pins to understand how to connect this IC. As you see here, we have some pins starting from pin 1 up to 8 and from 9 up to 16. And as usual, for most of the ICs, pin number 16 or the last pin on the right is the VCC, and the last pin here is 8 and it should be connected to the ground. So 8 and 16 are easy pins to be connected. And then we have something called chip select, and as you see it is active low. What do we mean by active low? It means this pin will be activated if you connect logic low, which means if this chooses or enables this chip, so the chip will be enabled and provides an output if we connect this pin to the ground. That is what do we mean by active low. So why do we need chip select? Because and you should study this in the computer architecture and organization course. If you have let's say this memory with this IC, but you have like 2 of them, and you want to build a bigger memory or a bigger RAM. So you have a size of 64-bit and you need like something like 128 bits. So what should we do in this case? You should draw another block like this one here. So the total will be 128 bits. So now when we are reading or writing to the memory, are we going to write to this one or this one? It depends on the chip select. If you select or enable this one, the data will come from the bus to this one. And by the way, if you have 2 blocks, both of them should be connected to the bus. So the bus is 4 bits. So the 4 bits that come from the bus should enter its data to this or this. It depends on the chip select. If you select this one, the data will come from the bus to here. If you select the second block, the data will come from the bus to the second one. And also this applies for the read and the write. So if you want to make this IC work, you have to connect this pin to the ground. And also we have another pin, which is number 3. It refers to write enable or write E. I don't remember what do you mean by E. Yeah, it is, as you see here, it is write enable. And also this pin is active low, which means we need to connect this pin to the ground in order to write to the memory. And if you want to read, we need to connect this pin to 1. That is how it works. And then the other pins are very easy. You have some pins for the address, some pins for the input, some pins for the output. And because this is a 4-bit array, so we have 4 bits for each one of these. 4 bits for the address, 4 bits for the input, 4 bits for the output. Let's look at the address. So A0 up to A1, A2, A3, these are the pins for the address. And then we have another 4 bits or pins for the data input, which refers to 4, 6, 10, and 12. And for the output, if you are reading from the memory, the output that you will read, you should read it from these pins. 5, which refers to O1, O2 pin 7, O3 pin 9, and O4 pin 11. So if you are writing to the memory, the data should be entered through D, D1, D2, and so on. If you are reading from the memory, writing to the memory, you should write through D1, D2, and so on. If you are reading, you should read through the O1, O2, and so on. But we have a problem regarding the output here. The output is active low, which means the output that you will get from this IC will be the inverse of the output that it should outputs. Do you understand this point? So let's say that we are reading a value from the memory. Let's say this is our memory, and we have a value like this: 1 0 0 1 0 1 0 1, and you are reading, for example, this location here. So the output will be like this: 1 0 1 0. This output will be on pins 5 7 9 11. So but as you see, this is not the correct output. The correct output is 0 1 0 1, and that is why we need to connect these 4 pins to a NOT gate. The NOT gate, as you know, the NOT gate is used to provide or output the inverse. So if it is 0, it will output here 1. If it is 1, it will output 0. So that's why we are going to connect these 4 pins to a NOT gate or a NOT IC. So that is how it looks like. Now let's look at the connections. Before looking at the ICs, I am going to explain why do we need these switches. So first of all, do you see this switch? I connected here only one switch from these 4 switches. This one, the last one on the right. Why do we need this switch? Because we need to use pin 3 with this switch to enable the write or the read, to activate the memory for writing or activate the memory for reading. So if we turn this switch off, then we are writing to the memory. If we turn this switch on, then we are reading from the memory. That's why we need this switch here. So why do we need these 2 blocks of switches here? We need this one for the address, and as you see, we have 4 bits starting from pin 1 A0, pin 15, 14, 13. So instead, I am not going to connect the RAM today with any other units. I am just connecting the RAM alone, this box here. I am not going to connect to the bus from here or any other unit like this one. Just let's focus on the RAM only, because I want to take this step by step. And once you understand the memory connections, you can start connecting the memory, for example, to the MAR. Once you understand this connection, you can start connecting the memory to the bus and so on. So we need these 4 switches to determine the address that we need to read from or write to. And we need these 4 switches to write the data into the memory or to the memory. So let's say we have now address 0, right? Because all switches here are turned off. So if you look at this value, that means we need to write this value 1100 to address 0000, right? But that happens only if we turn this switch off. Because if you remember, if you turn this switch off, which is pin number 3, we are writing. But if you turn this switch on, you are reading. And in this case, these switches has no meaning here, has nothing to do with the RAM now, because we are reading, not writing. Okay? So now let's look at the connections. As you see, this is our IC, and this is how it looks like on real. I don't know if I have one with the number here. Let's see. Yeah, I have one here. I don't think that it will be clear. Yeah, it is 189. Okay, but it is not. If it is not clear, no problem. Anyway, you can see that pin 16 should be connected to the VCC, and as you see, I connected this pin to the VCC, the red line here, and pin number 8 to the ground. Here, pin number 8 is connected to the ground. Pin 2 should be connected to the ground, so I'm going to connect pin 2 to the ground. And now we need to connect, we have inputs, outputs, and the address. Let's start with the address. Pin number 1 to the first switch here on the right. And also don't mix the connections here, because pin 1 refers to A0, address 0. And the addresses should be like this: A0, A1, A2, A3. So this is bit 0, bit 1, bit 2, bit 3. So A0 should be connected to bit 0 here on the right. So where is A0? A0 is on pin number 1. So I am going to connect pin number 1 to this switch here. This is pin number 1. Let me see. Do you see the connections? Okay. Pin number 1 to this switch. And then pin number 15, which is A1, should be connected to the next switch, to the second switch here. So I am going to bring one of the lines here. This is to pin 15. Next, pin number 14 to the next switch. So pin number 14 to the next switch. And then pin number 13 to the last switch here. So this is pin number 13 here. Yeah. So now we finished the address connections. Let's now look at the data input. So the data input starts from pin number 4. So pin number 4 should be connected to the first switch on the right here. So pin number 4, I have some connections here. Pin number 4, 1, 2, 3, 4. So this is pin number 4. You will find that the connection here is a little complex because we have different pins for the same thing on different sides. So for example, the address can be found on the left side here and on the right side here. The same for D1, D2 on the left side, and D3 and D4 on the right side. So it is a little complex. Now we need to connect the next pin, which is, so this is D1. We need D2, which is pin number 6. So pin number, this is 4, 5, 6 here. So we should do like this. Pin number 6 here. Okay, I think, yeah. Okay, then pin number 10 to the next switch. So let's see if this can work. Pin number, this switch here, and to pin number, sorry, which pin here? Pin number 10. So I think, let's see if this works for the next one. Pin number 12. Yeah, this is for pin number 12. I think because I already prepared this. Yeah, so this is for pin number 12. Let's reconnect again. So the next switch to pin number 10, 9, 10. So it is this one. And finally, pin number 12 to the last switch. Pin number 12 to the last switch. Okay, so We finished the connections of the address of the data input. Now we need to see the output. So we can see the output by some LEDs, right? So that's what we're going to do. So where is the first output here? The first output is pin number 5. But don't forget that this is active low. So the output here is the inverse of the correct output. So we need to take the inverse of these values here. So that's why we have this IC. This IC has a number 74LS04. So I'm going, just because I don't have the data sheet here, so let me draw how this IC looks like. I think we discussed this IC many times before. So these are the pins. So from here it looks like this. Okay, and so on. And also we have another 3 on this side. So I think it is like this. I hope that I remember this correctly. So this is pin number 1, 2, 3, 4, 5, 6. And this is the whole of the IC. So we start pin number 1 from its left. So this is the hole here, and this is pin number 1. But before that, the last pin here should be connected to the ground as usual, and this pin to the VCC. As you see, this is to the VCC, and this is to the ground. Let's now start with pin number 1. So pin number 1 here from this IC should be connected to pin number 5 from the RAM. So let's do this. Pin number 5 here, pin number 1 here should be connected to, let's do this, should be connected to pin number 5, so it's not this wire, it should be this wire here, no, it should be this one. So pin number 1 should be connected to pin number 5. So 1, 2, 3, 4, 5. Yes, that should be correct. And then the output will be connected to a LED, but I'm going to do this later. So this is pin number 3, should be connected to pin number 7. So pin number 3 should be connected to, this is 1, 2, 3, should be connected to pin number 7. Where is pin number 7? I want to count correctly. So this is pin number 8, so this should be number 7. Yeah. Then the next one, pin number 5 to 03, pin number 9. So pin number 5 here, 3, 4, 5. Sorry. So pin number 5, yeah, it should be pin number 5 to pin number 9. Yeah, pin number 9 here. The last one is pin number, I think, pin number 10. Sorry, this is 8, 9, 10. So yeah, pin number 10 to 04 here, pin number 11. So pin number 4, I think I did something wrong, right? Let's revise the last pin. Yeah, so this is, yeah, that's right. So pin number 10 here should be connected to pin number 11 here. So 9, 10, 11. So pin number 11 to this pin here. Now we need to connect the LEDs. So the first LED should be connected to number 2. This is our LED, and if you remember, the small one here is the VCC, or should be connected to the positive value, and the large one from inside should be connected to the ground. Is it clear here? Yeah. So pin number 2 should be connected to this LED here, and then the next one so should be connected from pin number 4, right? So pin number 4, this is pin number 4, and then pin number 6 to the ground, pin number 6 to the ground, and finally pin number 10, right? It should be pin number 10. I'm not sure now, but if it is wrong, we will see a problem in the output, or the output will not be correct. So let's connect this to pin number 10. So where is the last LED? So the last LED should be connected to this pin, but I'm going to connect, I'm just going to add a connections to here so that the 4 LEDs are next to each other. So let's take a pin here. Oh, so where is the output here? Yeah, should be pin number 9. This is the output, not pin number 10. And then the LED to the ground. Yeah, the last one here, the last connection here is this pin number 3. So we should connect this one to this switch, because this switch will control if we need to write or read. So let's bring any connection here to this one. So it should be pin number 3. So this pin number 1, 2, 3. Sorry, it should be from this IC, not this, from this IC. So let's bring pin number 3, 1, 2, 3 to this switch here. It is a little short. Let me bring some another wire that is taller than this. Yeah, I have one here. This one. 1, 2, 3. I know that this video is a little long, and you can just increase the speed of the video. So now we are ready to connect the power supply. So I'm going to connect the power supply to here. This is to the ground, and this is to the VCC. And as you see, it works. That doesn't mean that it works correctly, but we can see that we have an output here. So now we need to understand what we need to do here. First, we need to read each address in this memory. So if you want to read, you should put this here like this, because this should be 1. Oh, so this is not correct, because this will be connected, this is connected to the VCC directly, so it is not going to be 0 or 1, it is going to be always 1. So this pin should be connected here. So I'm going to remove it from here and add it here to this side. So we need to read from the memory, and to read from the memory you need to turn this switch on, because if it is 1 we are reading, if it is 0 we are writing, and if we make this 0, as you see, we are not reading anything, and that is why you can't see any output. So let's read first from the memory, and then we can write any values to the memory and read these values to make sure that we wrote to the memory correctly. So let's start by reading. So we enable this switch, or sorry, not enable the switch, because enable means 0 because it is active low, but let's say that we turn the switch on to enable the reading, not the writing. So as we see, we have here these 4 bits for the address. So now we are reading the first, the first address here, which refers to this one, right? So the value in this address is 11 0 0. Let's move to the next address. So the next address has 1 0 1 1. Let's go to 2. So this is 2. As you see, it is similar to 1. Let's go to 3, similar to 1, 1 and 2. Let's go to 4. This is 4, similar to the other values. 5 and 6, 7. Let's go to 8. I am trying to read all values to see what we will have. Yeah, same. And then 1, and then 2, 3. Yeah, sometimes you will find that we have different information or different output. But anyway, let's start now writing to the memory. Okay, so do you see these switches? It is 1 1 0 0. So I'm going to turn them off, and then now address 0 will have a value 0 0 0 0 if we enable the right switch. So let's enable the right switch. It is now 0 0 0 0. We are not reading, by the way, but we can see the values. I should have connected some LEDs here, but anyway, we can see that these switches, all of them are turned off. So let's now read. If we read, we should see all of them off. So they are off. Okay, let's now put this value. Okay, so now we wrote this value because this is 0 now. So we wrote 1 0 0 0 to the first address. So I'm going to enable this. Do you see? Now we are reading. So we can see that we are reading 1 0 0 0, which we already wrote a few seconds ago. Now let's write to another address. So this is address 0. Let's write to address 1. So let's write this value. So now we have this value written to this address. So we can read to make sure that the data has stored correctly. So yeah, it works fine. Let's do this for this address, and as you see, we can do something like that. So now the data should be written now. The data, I think it has stored, so we can read. And as you see, yes, we have 1 1 1 0 1 1 1 0. So this is how the RAM can be connected, and this is how to write to the RAM, and this is how to read from the RAM. And also we understand now why do we need the 74LS04, the NOT IC, because we need to get the inverse of the output of the RAM, because we already mentioned that the output is active low, or the inverse of the correct output. In the next video, we should start connecting the RAM to the other components. So we can start with the memory address register, or we can also connect to the bus. That is what we're going to do. And also we have another topic that is very, very important, which is the tri-state buffer. So let's see what we are going to discuss next. That's all for today, and see you in the next video.